Hey, welcome back. Today I'm going to be going over this absolute value question that usually comes up on the second module of the SAT. Once again, thanks to Anico.ai for providing this specific question in their free resources tab. But before I get started on the explanation, please give this problem a try. Okay, so here, right, we're given a equation that has only one solution, right, and there's a constant k, and you have to find the value of k plus 4 divided by 2. So usually in these videos, I go over two separate ways to approach the problem. One Desmos and one using some algebraic way, right? Like concrete math itself. But I'm just going to be showing you the Desmos way because I actually think that's the perfect way to think about these absolute value questions. So first things first, right? Well, we're only really given one thing here, right? We're given this equation and there's a constant involved. So let's just first write that in. So you have 3 times the absolute value of x minus 1, right, equals 2x plus k, right? Actually, we're going to put these on separate lines because Desmos doesn't register it if you type it as an equation. So those are our two systems here, right? And you know that the equation has one solution. Well, if you think of this as a system, right? So like you can think of this as y equals 3 times absolute value of x minus 1 and y equals 2x plus k. Well, if it's a system, that means it only intersects at one point if it has one solution. So you have to find what value of k here makes it so that these systems only intersect at one point. And if you move the slider, right, eventually you're going to get that the value of k, right, is a good is a very good number here, right? It's a -2. So yeah, at k when k is equal to -2, these two equations or these two the system equation has only one solution, right? And that's at the point x equals 1 comma 0, or x equals 1, y equals 0. So now that we have found that value of k, right? So we found that k equals -2. What you can do is just plug that in, right? So you have -2 plus 4 divided by 2, which gives you 2 over 2, which gives you 1. So our answer choice is C. So yeah, again, this is actually a really simple problem if you think about it the Desmos way, right? Because all you have to do is adjust the slider until you see where these systems only intersect at one point. Now, I'm going to try to give you a framework to follow instead of just, telling you, hey, do this, move the slider. Um, I actually call this in my brain, right, a very specific thing, and I call this method the single point lock, right? The single point lock. And the reason is because the entire equation here, right? The entire system of equations here, it only locks onto one critical point, right? Where the solution count drops to 1. So like, for example, what I mean by that is like if k is some other number, right? For example, if k was 4, right? You would see here that there's two solutions, right? Because it intersects at 2 points here, right? If k was like -7, you'll see there's no solutions, right? But as soon as k reaches -2, right? Like right here, what happens, it locks onto that value, right? It locks on to that single point of that absolute value function. And that single point I'm referring to, right? Think about this. If we have a absolute value function, I'm referring to the vertex here, right? That's my single point here, right? So that's what I mean when I say it's a single point lock. This the value of k here, it locks on to that single point, which is the vertex, right? You can think of it as a transition point, right? It's where it goes from two solutions to one, or from like zero solutions to one solution, right? So that's why I call this a single point lock, and it's a good idea to memorize these like specific frameworks in your head because you can apply them right away when you're doing these complex problems, right? So for a single point lock, right, that's what I call this method. The key thing to to have is your equation has to have only one real solution, right? Because once again, you're focusing on a single point, right? Not multiple, single points. So that's why your equation has to have one solution, and second, it has to be an absolute value. And that's kind of where this method comes from, right? And again, this is applicable for any type of question where you have one solution and you have an absolute value. So yeah, hopefully that made sense. But if you have any questions about this method, leave it down in the comments. Please hit that subscribe and click on that like. And we also create videos daily to help you guys on your ACT or SAT prep. So if you want to be notified when our videos do come out, please hit the notification bell. But once again, I hope you really enjoyed this video, and I'll see you next time.